Welcome to this tutorial on Python functions for healthcare applications. In this video, we will learn how to write reusable, safe, and modular functions, which are the foundation of real-world healthcare software and AI pipelines. By the end of this tutorial, you will be able to calculate BMI, classify patients, and structure your Python programs professionally. Let's first understand what is a function. A function is a block of code that performs a specific task. Once defined your function, you can reuse it anywhere in your Python program. This makes your code cleaner, easier to read, easier to test, and easier to maintain. Python already has many built-in functions you probably use every day. For example, print. Print is a built-in function that's used to display output. Int. Int is a built-in function that's used to convert any floating point number into integer. And the len function returns the length of an object or counts items in a list. There are many more built-in functions that's used for everyday activity. Functions always use parentheses and they may accept parameters. In this tutorial, we will define our own functions and apply them to healthcare-related examples. Let's start by defining our first Python function using a healthcare example. Imagine a hospital system that needs to grade staff when they log in. And instead of writing print over and over, we can put this logic into a function which is reusable and organized. Create a new Python file and call it clinic.py. Then define the function by typing def welcome_message. The keyword def tells Python that we are defining a function, then followed by function name welcome_message. This is the name of the function that you can choose any descriptive name. Then followed by parentheses. The parentheses can hold parameters, but for now we leave them empty. And finally, we put colon. The colon indicates the start of the function block. Everything inside the function must be indented. This is the body of the function. Here, the body only has one line, print, welcome to the hospital management system. This is what the function does whenever we call it. At this point, the function is defined but not executed. For example, if you run this file, python space clinic.py, it prints nothing. To run it, we simply call the function like this, welcome_message parentheses. This function is called and the function call is outside of the function. Then when you run your file, python space clinic.py, you should see welcome to the hospital management system. And just like that, you have created a reusable block of code. Later, we will add parameters, return values, and more complex logic. But for now, this is your first functional building block for healthcare applications. Before we dive deeper, let's talk about function naming rules. Proper names make your code readable and professional. Here are a key rules to define a function in Python. Function must start with a letter or underscore. For example, def calculate_BMI. This function is a valid function name. It starts letter and use underscores in between calculate and BMI. You also start with underscore, for example, underscore helper. This is also a valid function name, but function never starts with a number. For example, 1 BMI. This is an invalid function name because function must start with a letter or underscore, cannot start with a number. Function can contain letters, numbers, and underscores. Function is a case sensitive. For example, calculate_BMI is different from capital calculate_BMI capital. And also avoid Python keywords to use as a function name, such as def, if, return, etc. Use descriptive or meaningful names. For example, compute underscore risk underscore score. This function name is a descriptive that describes a task that you are going to do, but not X. X doesn't describe the tasks. Follow PAP8 style, lowercase words separated by underscores. For example, def check underscore vitals. Check and vitals are two separate words, but you cannot use a space in between to define a function. Instead, use underscore to separate words and define a function. It is recommended to use lower cases. Following these rules ensures your healthcare code is safe, readable, and professional, especially when working on AI pipelines, patient databases, or collaborative projects. In healthcare applications, functions are used all the time to make code organized, safe, and reusable. For example, a single function can calculate BMI for a patient based on their weight and height, validate patient age to make sure input data is correct, flag abnormal vital signs like high blood pressure or heart rate, process lab results such as blood glucose or cholesterol readings, prepare data for machine learning models like predicting disease risk. Without functions, your code quickly becomes long, repetitive, and error-prone. By using functions, you write the logic once and reuse it wherever it is needed, keeping your healthcare programs clean, safe, and maintainable. Now that we know how to define a basic function, let's make it more useful by adding parameters. Parameters allow a function to accept input values so it can perform different calculations depending on the data you give it. A practical healthcare example is BMI or body mass index, which is calculated as BMI equal to weight in kg divided by height in meter square. We will create a function that calculates BMI for any patient. Open a new Python file and call it BMI underscore calculator.py. Then define the function with parameters for weight and height. Def calculate underscore BMI, then in parentheses, weight underscore kg, comma, height underscore m. This function has two parameters, and each parameter are separated by comma. A function may contain more than one parameter, so you can separate by comma if it has more than one. Parameters are special variables that used to accept user input and defined inside the parentheses of a function. So here we calculate a BMI. We just use the parameter weight underscore kg divided by height m power 2. So we store the result of the calculated BMI into a variable BMI, then print that result using print statement. Therefore, weight underscore kg and height underscore m are parameters that allow the function to accept different patient values. Inside this function, we calculate the BMI using the standard formula. We then print the BMI so we can see the result. To see the result, we call the function with a real-world example. Therefore, outside of the function, we call calculate underscore BMI and we pass the value 70, 1.75. 70 is the weight of a patient and 1.75 is height of a patient. When we run the program now, it will print out BMI 22.851 something. This shows how the same function can now be reused for any patient simply by passing different arguments. So we can call the function more than one, pass different arguments, 90 and 1.7. Then the result is 31.14. Functions with parameters are flexible and reusable. Parameters act like placeholders for input values. This approach keeps your healthcare code clean and easy to maintain. In healthcare systems, we don't just print results on the screen. we often need the result for further calculations, reporting, or machine learning pipelines. That's where the return statement comes in. Let's update the BMI function to return a value instead of print a value inside the function. So we just avoid printing the BMI. Then instead we use return BMI. The return BMI sends the calculated BMI back to the caller when the function is called. The function no longer prints anything inside when you run this program. This makes it flexible and reusable in different contexts. To print out the result of the calculated BMI, we just store the returned value in a variable, for example, patient underscore BMI, and then we can print out that stored value using print statement. For example, patient BMI 22.85. That's it. Now, patient BMI can be used in other functions like classifying a risk or saving to a database. Therefore, printing is for humans just to see the output. Returning is for programs, so the value can be used elsewhere. Machine learning pipelines, automated alerts, or patient dashboards require returned values, not just printed text. By returning values, your functions become building blocks for complex healthcare applications. Now that we can calculate BMI, let's take it a step further and classify patients based on their BMI. This is a common practice in healthcare. For example, to flag patients who may be underweight, overweight, or obese. So let's define a function to classify BMI. Def BMI underscore category. This function takes a parameter BMI. Then we just apply a conditional statement to compare the values of BMI and to return the status of the patient. If BMI less than 80.5, that returns underweight. And if BMI less than 25, that returns normal weight. And if BMI less than 30, return overweight. Else, it returns obese. So we use these conditional statements such as if, elif, and else to check the BMI value. Then the function returns the category as a string. This keeps the logic separate from the BMI calculation, which is a good practice. Now let's call the BMI underscore category and combine them. We already stored the calculated and returned BMI into BMI variable. And now we just use the returned BMI as an argument to a BMI underscore category and store that result into category. When you print BMI, it prints the result of the calculated BMI. When you print category, it prints out the category of a patient. So in our example, BMI is 22.85 and the category is normal weight. So what will happen if we just use the second example, BMI 2, as an argument to a BMI category? Then we store into category 2, then print the BMI 2 and print category 2. Now the BMI is 31.14 and the category is obesity. This is modular design. Calculate underscore BMI only calculates the BMI, and BMI underscore category only classifies the BMI based on the BMI result. Each function does one job well, making your healthcare programs easier to maintain, test, and reuse. So in this case, we use the result of the function of calculates BMI as an input to the BMI underscore category. In healthcare systems, some information is optional or has common default values. For example, a patient profile may include a country, but if it is not provided, we can set a default. Let's define a function with a default parameter, def patient underscore profile. This function takes three different parameters: name, age, and country. So the default value for country is unknown. So in this case, we print name, age, and country. The country unknown sets a default value. If we don't pass a country, Python automatically uses unknown. So the default parameters makes your functions more flexible and safer. Now let's call the function patient profile and pass Leah, 32. In this case, we didn't pass the values of country, so it just uses the default value unknown. Let's call one more patient underscore profile has Asibek 45 Ethiopia. Now the country is just replaced by Ethiopia instead of unknown because we just pass the value for country. So it prints out Leah 32, country is unknown because unknown is the default value for country. And the second one is Asibek 45 and country Ethiopia. So the default parameters allow to skip optional values without breaking your code. They are especially useful in healthcare applications where some patient data may not always be available. Combined with keyword arguments, they make your code clearer, readable, and robust. Sometimes you may have parameters in a function, and remembering the exact order can be tricky. That's where keyword arguments come in. They improve clarity and reduce errors. For example, let's call our function patient underscore profile, and let's reorder the parameter names, age, name, country, but the correct order is name, age, country. Here, we just assign values for each argument. Therefore, each argument is explicitly assigned to a parameter. Python matches the values to the correct parameters. So, the order no longer matters in this case. So, this is called a keyword arguments. You just assign values for each keyword when you call the function as an argument, and the order doesn't matter. It just takes the order of the arguments based on the values assigned to that argument. Why this matters in healthcare? Large hospital systems often have functions with many patient details. Keyword arguments help prevent mistakes like swapping age and weight. They make your code readable and maintainable, which is critical when dealing with sensitive patient data. Sometimes a function needs to give us more than one piece of information. For example, when analyzing a patient's blood pressure, we might want to return the systolic value, diastolic value, and a status message. Now let's define a function analyze underscore blood underscore pressure. Then this function takes two parameters, systolic and diastolic. In the body of the program, we just compare the values of systolic and diastolic. Then it prints out the status of the patient. If systolic less than 120 and diastolic less than 80, update the status. The status is normal. Else, the status needs attention. Now, the return statement just returns systolic, diastolic, status. So, the function checks the blood pressure values, returns three values, systolic, diastolic, and the status message. Python automatically packs them into a tuple. When you call the function and unpack values, we just comma separated like systolic, diastolic, status. Then assign two values, the systolic and diastolic, into analyze underscore blood underscore pressure, and the function will check the systolic and diastolic, and then returns both systolic, diastolic, and status in a single tuple. Then here, it's just sequentially assign the result into the variables. The systolic is 130, diastolic is 85. The status is needs attention when you print out this program. Here, each returned value is assigned to a separate variable, separated by comma. This makes it easy to use the values in other parts of your program, like generating alerts or updating patient records. So, returning multiple values keeps your code clean and organized. Functions can provide all relevant information at once. This is particularly useful in healthcare pipelines, where multiple matrices often need to be processed together. As your Python programs grow, it is important to structure them professionally. We want a clear entry point for our program. That's where the main function comes in. Now let's define a main function, def main. Then we call all the functions inside the main. That is an entry point for our program. So the main function organizes the key steps of your program and an entry point to the other programs in your code. Here, we calculate a patient's BMI and classify it. When we call main in a professional Python program, we often use a special line. If underscore underscore name underscore underscore equal, in quotation, underscore underscore main underscore underscore, then put color. Then we call the main function here. Devil underscore name, devil underscore pronounced as then their name is a special Python variable. When a Python file is executed directly, this special variable is set to the devil underscore main, devil underscore. This tells Python run the code inside this block only if the file is executed directly. If the file is imported as a module in another program, the code inside this block won't run automatically. So now, when you run this Python program, the Python automatically executes the special variable, and then the special variable just calls the function main, and main function just calls the other functions such as calculate BMI and BMI category. Then the output will be displayed out on the screen. Why this matters in healthcare? It prevents unintended execution when sharing or reusing modules. It also allows your code to be imported safely into larger hospital systems or data pipelines. It is considered industry standard practice for professional Python projects. All right, in healthcare AI, functions are everywhere. They prepare data from patient records. They compute features like BMI, risk scores, or lab value ratios. They validate inputs, ensuring data is clean and safe. They power pipelines, letting machine learning models run reliably. If you can write clean modular functions, you are already thinking like a machine learning engineer. Finally, functions make your code reusable and safe. One function equal to one responsibility. Keep them focused. Use parameters and return values to make functions flexible. Structure your programs with main function for readability and safety. This is the foundation for building healthcare AI systems. Once you master this, you can start creating real-world data pipelines, analytics tools, and predictive models. Thanks for watching.